Today we're going to talk about one application of the law of sines and the law of cosines, which is called forces. Now forces, what we're going to talk about with forces is this. We are going to have two forces, and these two forces are going to either push or pull an object in different directions. And so I'm going to demonstrate this forces situation where the two forces are pushing or pulling an object in different directions. So what I have here is I have this box, and this box is my object. And this over here, this pipe cleaner, which is what it is, represents a force that's pulling the box in this direction. And this pipe cleaner, the smaller one, is another force. This is the second force that's pulling the box in this direction. The length of these pipe cleaners represents how much force is being used to pull on this box. So I just have a little demonstration here that says this is the strong person because this is the longer pipe cleaner. This is the greater force. And up here, this is the weak person because they're not pulling on the box with as much force. So if two people, a strong person and a weak person, start pulling on this box, the strong person in this direction, the weak person with less force in this direction, what we're going to talk about is where does the box eventually move? Well, if they both pull at the same time, the box is going to go somewhere in between the strong and the weak person. It's not going to go directly towards this strong person. It's not going to go directly towards this weak person like it would if they were pulling on it by themselves. But when they pull on this object together, then the box moves somewhere in between them. And what our job is sometimes to figure out what the resultant force is. And a resultant force is just what is the direction that this box moves and how far did it move. So a resultant force, and I'll show you all of these with the diagram, this green could be something called the resultant force. And this resultant force goes somewhere in between the force that this weak person is pulling and this strong person is pulling. And the box actually follows this line, this green line that goes in between. This is called the resultant. And it just means that that's the direction that the box is moving when the weak and the strong person pull on it. So there's a kind of a picture of the whole situation. This could be a box, it could be a desk, it could be any kind of a heavy object that two forces, and I always use people as forces. It doesn't have to be people, but if two forces are pulling an object in two different directions, where does the heavy object eventually move? So we'll have all different situations about these forces problems. So the effect is that of a single force, and that's what I showed you with the green, that single force in a direction between the two forces. Okay, these forces, when you draw them out, they're represented by a line segment. This is also called a vector. A few people are in physics, and in physics I think you draw vectors, but vectors are just, all they are is a line with an arrow on the end. Or that's what lines have actually, is the arrow on the end. And it indicates the direction that the object is being pulled in. Okay, so the length is also called the magnitude. The arrow is the direction. And when two forces act on an object, like what I just showed you, the single force that is the combination of the two forces is called the resultant. So this was the weaker person. This object was the box. This was the weaker person. This was the stronger person because the force is longer. This is a shorter line. This is a longer line. And the resultant was like that green pencil that I showed you, that's the direction that the box moves. And that's how far it actually moves. The resultant is how long it moves. And so what we actually have here is, before these two dotted lines are drawn, we have the white pipe cleaner, and the green pencil that I showed you on the box down here. And what you can do to figure out how long this resultant is you can draw a parallelogram by drawing a dotted line from the top of the first force over and make a parallelogram, so the top of this first force goes parallel to the lower force, and then you can draw this dotted line which is parallel to the force 1. So these two lines on the parallelogram are equal to each other. They have the same slope and the same length, and these two are both perfectly horizontal lines, and they both have the same length. This dotted line has the same length as this force 2. And that's how you start drawing them. So I'm going to go through an entire example to show you how to do these forces problems, or how to set them up and solve them, and then we'll go through a couple on our own. So here's how they're usually worded. You have two forces, and then they tell you what the magnitude of the force is. We have 25 and 15 pounds. Usually when you're talking about forces in this course anyways, the magnitude, this would be like the strong person that I told you about, and this would be like the weak person. The strong person has the larger magnitude, and the weak person has the smaller magnitude or length. And then it tells all different kinds of information. It just depends on the problem. In this problem, the angle between them, so the angle between these two forces is 75 degrees. And so here's how you set it up. Here's the object, or I often just put a box there because that was like our pink box. And the weak person is pulling with 15 pounds. The strong person is pulling with 25 pounds. And so what we want to do is we want to set up a parallelogram. So like I was saying, what we can do is we can draw a parallelogram out of the 15 and the larger force here. And I've done that down here for you. So here's the parallelogram, which is just, you could draw this yourself up here. It's just a perfectly horizontal line that's the same length as this. And then you could draw the other dotted line, like I showed you up here, and you're creating a parallelogram out of the smaller and the larger force. And here's the angle between the two forces of 75 degrees. And so when you do that, you can then draw your resultant, which is the diagonal that goes from the object up to the other corner. So this B is the resultant in this diagram. The resultant is B. And there's a note here that this whole thing is 75 degrees, but this angle A is not 75 divided by 2. All right, so please put this down. These two angles are not equal to each other. This angle right here and this angle. This is a smaller angle. This is a larger angle. The two of them together add up to 75, but they are not equal to each other. They add to 75 degrees because that's how they were originally up here. All right, so now what we want to do is, once we draw the diagonal in, then we have two triangles. These two triangles are equal to each other. And usually I pick the lower one to work on, but you don't have to. So here's a lower triangle down here, and you fill in all of the information that's given to you. This force was 75 or 25. This force is the same as this force, which is 15 because it's a parallelogram. And remember, you can get this 105 degrees because we were given 75 over here. 180 minus 75 that's given is equal to 105, right? These two base angles are supplementary. They add up to 180. So they want us to find the magnitude of the resultant. Sometimes they want us to find other things, but on this one, the magnitude of the resultant. So then we have to ask ourselves, what information do we have? We have side angle side. I usually put A, B, and C on these triangles and label the sides A, B, and C, and then figure out which law I want to use. So we have our ABC chart like we've been filling out, and we have capital A, which we don't know. It's not a half a 75. We don't know capital C, but we do know capital B. Angle B is 105 degrees. We know little c is 25. We know little a is 15. And if we do our little trick to see if we use the law of sines, we don't use the law of sines, we use the law of cosines. Can't use law of sines. So the law of cosines says we're trying to find little b, so we set up the law of cosines. B squared equals a squared plus c squared minus 2ac cosine of b. That's the law of cosines. And then we just fill in our little 15 squared, 25 squared, 2 times 15 times 25 times the cosine of 105. When we put this in our calculator, take the square root, you get 32. So that is the magnitude of the resultant. And the magnitude, remember, is the same thing as the length. 32 pounds. All right, so let's do a couple other situations. Here's another situation. Now they're telling us what the resultant force is. The resultant force is 143 pounds. And here's our heavy box down in the corner to move a heavy box. And two forces act at angles of 35 degrees and 40 minutes and 47 degrees and 30 minutes with the resultant. And now what they want us to do is find to the nearest pound the magnitude of the larger force. Now the larger force is always the one that goes horizontally. And when you set up, when you draw this picture, you draw the horizontal line as the larger force. You draw the smaller force coming up in this direction. And because this angle is not split exactly in half, you have a larger angle up here and a smaller angle down here, like I showed you on the other page. They're not equal to each other. So we're given 35 degrees and 40 minutes as the forces act at angles with the resultant. So this is the resultant. So the other force is 47 degrees and 30 minutes. So this is the smaller, this is the larger. Make sure you draw them correctly. And so now we have a triangle here that we're going to solve. And it's called A, B, and C. And because this angle up here was 47 degrees and 30 minutes, this angle right here is 47 degrees and 30 minutes. Because two parallel lines cut by a transversal alternate interior angles are congruent, if you remember that from geometry class. So this angle is equal to this angle. And now if we have two angles and one side, we have angle side angle. And angle side angle allows us to use the law of sines. If you want to set this up into our ABC chart like we like to, ABC. Angle A is 35 degrees and 40 minutes. I haven't made my this big enough. Angle C is 47 degrees and 30 minutes. And then little b is 143 pounds. Now when you add those two up and subtract from 180, I've already done the math for you. This angle B turns out to be 96 degrees and 50 minutes. So here's the math to find angle B, because you know they all add up to 180. And then you have the law of sines. B over the sine of B equals C over the sine of C, because they want us to find the larger force. This is the larger force from our picture. The larger force is C from this picture. And so when you go through the law of sines and cross multiply, you get, and round, you get C is 106 pounds. This is the larger force. Magnitude. Which means the length. All right, so it's just a couple different situations with forces. And now what we're going to do is we're going to do a couple of examples here some exercises. So they all give us different information depending on what the problem looks like. So now we have, if two forces of 30 pounds and 40 pounds act on a body. So my first job is to set up my larger force as a horizontal line, and that's 40. My smaller force comes up at 30 pounds. And then what I do is I immediately draw the parallelogram, because I know this is a forces problem and it requires a parallelogram, and I connect the two diagonals, or I make the longer diagonal here. And it acts on a body with an angle of 120 degrees between them. So this entire angle right here is 120 degrees, which this isn't really drawn appropriately because 120 is obtuse, so it really should come back this way. But it really doesn't matter how you draw your problem, as long as you know if this is 120, then this angle is 180 minus 120, which is 60 degrees. So here's a 60-degree angle right here. Even though it doesn't look like one, it's still 60 degrees. And it says find the magnitude of the resultant. So this is like the first example that I gave you. So this side over here is 30 because these are both the same. And we have a triangle that we're going to use down here that we know the two sides and the angle in between them. And if we call this ABC, then this is little b, this is little a, and this is little c. And just like the example that we did before, we have b squared equals a squared plus c squared minus 2ac cosine of b. That's the law of cosines. So a is 30, c is 40, 2 times 30 times 40 times the cosine of the angle in between them. So now it's time to pull out our calculators. Make sure the mode is set to degree mode. And then we just plug it into our calculator. 30 squared plus 40 squared minus 2 times 30 times 40 times the cosine is 60. And b squared is 1300. And if you take the square root of that, take the square root of both sides, you get b is equal to 36 to the nearest pound, 36.055. ... and that's equal to 36 pounds. So there's your answer for the first one. Second one, two forces act on a body. So here's your body or your box, whatever the object is. So here are your two forces. The measure of the angle between the 34-pound force, so we'll just mark this as the 34-pound force, and the 40-pound resultant. So we don't know what this other force is. It really doesn't matter which one that we write is a 34, as long as we've got the resultant drawn in here, and that is a 40-pound resultant. And the angle between them is 60 degrees, so we'll mark that as 60 degrees. And we want to find the magnitude of the other force. So we want to find this. I guess we could call this A. This A is the same thing as this A because these two are the same. And so now what we have is we have side, angle, side again. And when you have side, angle, side for this triangle down here, you're going to use the law of cosines. So once we find this side here, this side is the same thing as the other force over here. So we have law of cosines. A squared is equal to, I'll call this A, B, a C, like we usually do. And here's little b, and this is A. Sorry, this is C. So A squared equals B squared plus C squared minus 2 times 40 times 34 times the cosine of the angle in between them, which turns out to be 60 degrees. So we'll put that in our calculator. 40 squared plus 34 squared minus 2 times 40 times 34 cosine is 60. Hopefully I typed that all in right. And you got A squared is 1396. So take the square root of both of those, and you get 37.36. With a lot of others, and to the nearest pound, it's approximately 37 pounds. Example number 3. When forces of 12 and 8, so you have two forces, one's 12, the other's 8, the magnitude of the resultant is 15 pounds. So now you know that this is 15. Find to the nearest degree the measure of the angle between the resultant and the larger force. So here's the resultant and here's the larger force. You're going to try to find this angle down here, which we call angle A if we set up this triangle as ABC. Here's our triangle down here. So since this is 8, this is 8. 8 is A, 12 is C, 15 is B, and we want to find angle A. Well, if we want to find angle A, we have side information, which makes us use the law of cosines. So the law of cosines says if we're finding angle A, then we have to start out with little a. A squared equals b squared plus c squared minus 2 times b times c times the cosine of big A. And then we have to modify it. We have to move the b squared and c squared because we're finding an angle. So we have to subtract b squared, we have to subtract c squared from both sides and divide both sides by this negative 2bc to get the cosine of A. If you remember, that's the modified law of cosines. And now we can just plug in the A, B, and C information. So I'm going to set up a fraction in my calculator, and A is 8, and B is 15, and C is 12. A squared minus B squared minus C squared all over negative 2 times times B, which is 15, times C, which is 12. Got to make sure that's right. A squared minus B squared minus C squared. Okay, so that's right, and that's the cosine of B. So we've got 61 over 72. So the cosine of A is equal to 61 over 72. And now do second cos of that answer, and 32 degrees to the nearest degree, it says. So second cos or inverse cos of that answer, and angle A is approximately equal to 32 degrees. So remember, when you're finding an angle and you have side, you have to modify that law of cosines. And then the last example, two forces act on a body. So we've got a larger, so the resultant force is 50 pounds. So we know the resultant is 50 pounds. The angles between the resultant and the forces are 25 and 38. Well, remember, the larger angle goes on top, so he's 38 degrees and he's 25 degrees. And if you add up 38 plus 25, together they make 63 degrees. So this angle, 38 plus 25, is 63 degrees. And so this angle over here is 180 minus 63, which is 117 degrees. Whoops. Here's the little bit of math I did. 38 plus 25, so together this is 63. And then this angle over here is 180 minus 63. So here's 117 degrees. And then this angle up here is the same thing as this angle up here. Like I showed you before, this angle is equal to this angle because of the parallel lines cut by a transversal. So if you want to call this A, B, and C, this 50 is little b, and we want to find the smaller forces. Well, this is the smaller force. This A is the same thing as a smaller force because it's the smaller of the parallelogram side. So since we're finding A, we do A over the sine of A is equal to what other? We know B. B is the resultant. sine of B. So we don't know A, but we know angle A is 25 degrees. B is 50, and angle B is 117 degrees. So we just do A is equal to 50 times the sine of 25 degrees. Oops, if you can read this. All divided by the sine of 117 degrees if you do the cross multiplying and dividing by that. So we'll just plot that into our calculator using our fraction bar. 50 sine of 25 divided by the sine of 117. So the smaller force is 23.7, and it doesn't say how to round it. So since it doesn't say, I guess I won't round it. 23.715777818 pounds, because these are in pounds. So here, that's the last example. So you can see there's all different situations with forces problems, different given information and different information what they ask for. But that's it for tonight, and see you tomorrow.